Okay, so you sent me a few questions, and they were all over minimum sample size required to estimate population proportions, or this one you're estimating a population, finding the minimum sample size for a mean, and then this one you're using the margin of error and population to find the minimum sample size required to estimate a mean. So these two are means, and then this one is going to be a proportion. So take a look at your formula sheet. You're going to be using one of these, right? For the first problem, we're going to use this. Well, let's see if we know p hat or not. It says p hat and q hat are unknown. So we're going to want to use this one right here. So it's going to be z alpha over 2 squared times 0.025 divided by your error squared. So let's work out this first one. So it says that the margin of error is 0.006, so we know E is equal to 0.006. And then the other value, whoops. The other value you need is you need that z alpha over 2 value, right? So let me see if I can make this z alpha divided by 2. Oops. Anyway, it's that critical value, right? How do we know what that is? Well, if we are using a confidence level of 96%, ooh, that's a problem because we only have 90, 95, and 99. So it's going to be a little harder for us to find that value. I think I'm going to actually end up giving credit for this problem because we don't have that value. But let's look at the other ones. All right. So let's say that this was 95%. Okay, if that was a 95%, we would use a critical value of 1.96, okay? So, sorry, you won't see that. There'll be 90, 95, or 99.5 on the on anything we're going to see. So, if we're going to base this off of 95%, the critical value is 1.96, and this is on the formula sheet. So when we plug that in, it's going to be, let's look at the formula sheet again. It's z alpha over 2 squared, so it's going to be 1.96 squared, and then we're going to times it by 0.25, so 0.25. And then I like to hit enter if you want to just divide it by. We're going to divide it by our E, which we said was 0.00006 squared, right? And then we would round this up, so this would be 26678. You always round up to the nearest whole number. So if it were 95, we would say n is equal to 26678, okay? Sorry about this being a 96%. I'll definitely make sure that it's always 90, 95, or 99. Okay, so this one says, use this given information to find the minimum sample size for a mean. So we're going to be working off this one right here. So you're going to do everything on the inside first and then just square it at the end, okay? Let's see the values we have. It says 95% confidence interval, right? So the 95% confidence. What would the critical value be? Same thing, right? It's 1.96, right? That's that z alpha over 2 value. The mean is within 2 points, so we're going to use 2 for our error, right? And we have a standard deviation of 64, okay? So those are the pieces we need to plug into this formula. So I'm going to kind of keep that off to the side so we can refer to that. So z alpha over 2 is 1.96 times our what comes next is our standard deviation, which we found was 64, and then we're going to divide that by our error, which is 2. And then we are going to hit enter, and then we're going to square our answer, okay? So make sure you get the result of that and then square it. So this one would be 3934 because we always round up, okay? So this one n is equal to 3934 because we round that up. All right, let's take a look at this last one. It's a mean as well. They tell you that your error margin is 1.2. Our confidence level is 90%. Let's look at what the critical value would be for 90%. If it's 90%, our critical value is 1.645. So our critical value is 1.645. And then the last thing we need is our standard deviation, which is 2.7. Okay, we're going to use the same formula that we did above. We want to work everything out first and then square it at the end. So it's going to be, this is, again, one more time, critical value times the standard deviation divided by the error, and then we square it. So critical value 1.645 times the standard deviation, which was 2.7, divided by our error, which we said was 1.2. And then I'm going to square the answer. And we get 13.699. We're going to round that up to
14.
And is equal to 14. So I hope this helps. If you have any other questions, let me know. I'll go back and take a look at this quiz question for you because that should not have been 96.